This episode of the podcast is going to review how we name compounds. In class, we use the special naming chart, the dichotomous key, to help us figure out how to name compounds. We're going to quickly review this using some of the slides that we used in class. Whenever we find out that we have to name a binary ionic compound, we're going to use the simple method that is on the screen. The first step is to figure out what is the first element. On our chart, it's the positive ion. And whenever we look at a chemical formula, the first element is going to be the positive ion. Now, if you watched the episode on oxidation numbers, we know that lithium has an oxidation of 1+, because it's in the alkali metal group. And that nitrogen would be a 3- in this case. At any rate, the first element is always going to be our positive ion. And we'd write down its name. And Li stands for lithium. So we write down lithium. That's the beginning of the name of this compound. And the second element, we have to write down the suffix IDE to that name. So it's nitrogen. So we write down nitrogen, but we're going to obviously drop the OGEN to add the ending IDE. And what we have here is a compound called lithium nitride. So let's look at some other examples. CaO stands for calcium. It's its first element. That's the positive one. And the second element is oxygen. Drop the YGEN and add IDE, so it's a calcium oxide. Na2O, that's Na stands for sodium, and O stands for oxides, that's sodium oxide. BaCl2, that's barium, and Cl2 stands for chlorine, but we're going to drop the INE and add IED, and we end up with barium chloride. And the final compound here, bottom, is calcium nitride. Sometimes it's necessary to name compounds that contain what we call complex ions. Usually, these are those compounds that have more than 2 elements that are being put together. We have this list of complex polyatomic ions. You'll find this on the sheet that I gave you in class to help name our various types of compounds. So the first thing we need to do is we need to find out what is the first element, which is usually the positive ion. Right? In this case, it is potassium, K. It has an oxidation number of 1+. We know that because it's an alkali metal. That's its oxidation number, 1+. So that is the first name. So it's potassium. Then we need to look at the second ion, the negative one. This is a polyatomic ion because it has 2 elements involved. It has sulfur and it has oxygen. So you need to go to your polyatomic ion list. Take a look there. This is SO4. And it's got a 2- oxidation number, and its name is sulfate. So that's its second name, potassium sulfate. And that's it. That's how we name a complex ion. Let's look at some more examples. NaOH. First task is to find out what is the positive ion. Sodium is the positive ion. It would have a 1+ oxidation number because it's an alkali metal. Write down the element sodium. And for our second polyatomic ion, we look on our chart, and it's OH. And OH stands for hydroxide. It has a -1 oxidation number. So it's sodium hydroxide. For our next one, we've got calcium. Calcium is an alkaline earth metal with a oxidation number that is 2+. Write down the element name calcium. And the next part, we have a polyatomic ion that's CO3. That is carbonate. The 2 minus oxidation number. So we write down the name carbonate. So that's calcium carbonate. Okay, the next one, Sr, is our positive ion. It's 2 plus. It's an alkaline earth metal. It's strontium. And just like before, for sodium hydroxide, OH is hydroxide. Oxidation number of 2 minus. It is 2 minus because we have 2 hydroxides. So it's sort of like saying 2 times negative 1. And finally, Ba. And the last one here is barium. And barium is an alkaline earth metal, so it's got an oxidation number of 2 plus. And ClO is our polyatomic ion. We gotta look it up. There it is. It's chlorate. Now that has an oxidation number of 1 minus, but it's times 2. So that gives us 2 negative for our oxidation number of ClO3, but we have 2 of those. So there's our answers for those samples. The key here is to first find your first element, and then for the second one, look it up on our chart for our polyatomic ion. Alright, and the last thing we need to remember when we're naming compounds, some of our compounds are not ionic, they're covalent. So these are the rules for naming a covalent bond compound. Alright? So the big change is that we have to find out how many of each element is being represented in atoms. So let's take a look at that. What would you name water? Water is a covalently bonded compound. We have 2 hydrogens and 1 oxygen. We want to know what it would be its chemical name. Now, when we're naming a covalently bonded compound, we need to first write the name of the first element. So we write down hydrogen. The next step is to write down how many hydrogens we have. It's going to be dihydrogen. Di for 2. And then you want to acknowledge the second element, or polyatomic ion. In this case, it's oxygen. You write down the root, then you add the IDE ending. So it's dihydrogen, and the number of oxides we have is 1, so it'd be monoxide. It would also be acceptable to write down dihydrogen oxide for this molecule. Let's look at some more examples. For the first one here, N2O, you write down the first element is nitrogen. You write down how many nitrogens we have. We have 2, so it's dinitrogen. And we have 1 oxygen. We drop the YEGN and add IDE. And the number is 1, so we write down monoxide. This is dinitrogen monoxide. Dinitrogen oxide would also be acceptable. This one here, we got nitrogen. We have 1 nitrogen, so it's 1 nitrogen monoxide. We have 1 oxygen, so we indicate that. The third one, we have nitrogen again. This time it's 2 nitrogen, so it's dinitrogen. And we have 5 oxygen, so it's pentoxide. Remember, oxygen, drop the YGEN at IDE. Okay, for our fourth one here, we have carbon. We only have one. So it's monocarbon dioxide. Also, except we'll say carbon dioxide. And then last one's CF. It's monocarbon monoxide. Or just carbon monoxide. The key to naming any of these compounds is to use the chart from class to help organize how you do each of the steps. Remember, it's relatively simple and we're using very simple compounds. To name very complex compounds, you would need additional steps. This concludes this episode of the podcast.